Welcome to qnawire.
We want to know what is going to be the acceleration of the box, considering that the force of B is going to be equal to 0. There's going to be no friction at all, and the only thing that is going to occur on this case is that the force is going to generate an acceleration on the x-axis. The acceleration on y needs to be equal to 0 because this guy is just simply staying on the ground throughout the whole movement. So what we're going to have is that the sum of the forces on x is going to be equal to the mass times the acceleration, and on the x-axis, our force diagram is going to look like this. We're going to have our mass, which is going to generate a force of weight equal to minus mg. Actually, let me put the minus directly over here because of the coordinate system. We're going to also have a normal force. On the x-axis, we're going to have, due to the force that is being applied on this direction, what we can put directly is that oops, with respect to the horizontal, recall that the angle theta over here needs to be equal to the angle theta over here. So this is going to be theta A, okay? And this is force of A. What we can see is that on the x contribution, the force on A is going to be equal to Fa times cosine of theta A. Just for completion, let's write down the sum of the forces on y that needs to be equal to 0. And this is going to be equal to the normal force minus mg minus Fa sine of theta. So if you're asked to later find the value for the normal force, you can solve it as such. In this case, since we're only going to answer for the acceleration, we're going to focus on this part and we're going to answer the two significant figures. The acceleration would be equal to the force on A times cosine of theta A divided by the mass. This is going to be 18 newtons times cosine of the angle, which is 84 degrees, divided by the mass of the object, which is 6 kilograms. The value of acceleration is up to two significant digits, 0.31 meters per second squared. So 0.31 meters per second squared. And that would be all. Thank you very much and have a good one.